Hello Math World. Today we are going to complete the square to transform general form quadratic equations into vertex form. Then we will take our new equation in vertex form and graph that quadratic function. We are now going to start completing the square. You can use the box at the right of your note sheet in order to fill in all of the steps, but I'm just going to write them as I go. So first thing we are going to do is we are going to make sure that the quadratic is equal to 0 or y. So let's check. We have y equals x squared minus 6x plus 10. So the y is completely isolated by itself over on the left side. So we are good. Our second step is to make sure that the a value of our quadratic is equal to 1. So let's check on that. My a value is the number that is the coefficient in front of the x squared term. So in front of this x squared term we have a 1. So we are good there. Our third step is to take our c term and slide it to the right. So our c term in this quadratic is plus 10. So we are going to take plus 10 and move it over to the right. Then, after we move it to the right, we are going to insert a plus square and a minus square in between our old quadratic and the 10. So this is what that will look like. Y is equal to x squared minus 6x plus square minus square, and then the plus 10 that we took from the original and just slid it over to the side, right over here. Okay, now we are going to figure out what goes in those squares. We are going to complete those squares by doing b divided by 2 squared. So before we do b divided by 2 squared, we need to know what b is. Well, b is the coefficient in front of the x term, so the b value is -6. So off to the side on your paper, take your b term, divide it by 2, and square the entire expression. So we have -6 divided by 2, which is -3 squared, and -3 squared is +9. Now we're going to take that number and insert it into our 2 squares. We're completing those squares. Okay, so because I ran out of room on the other page, I'm just going to continue on the next page here. And so this is exactly where we left off. So we just plugged 9 into both of these squares. We have a +9 and a -9, and our +10 hangs out on the other side. Now we are going to group off the first 3 terms to form a perfect square trinomial. So our first 3 terms are the x squared, the -6x, and the +9. So I'm going to insert parentheses before the x squared and right after my first box. This makes a perfect square trinomial because now we can factor this expression. This is called a perfect square trinomial. So from here we can see that we have grouped off first terms 1, 2, and 3. In order to factor this, just so you know, if I ever use PST, that stands for perfect square trinomial. So in our next step, we are going to factor the perfect square trinomial by thinking to yourself, and this is how you factor every perfect square trinomial, what 2 numbers multiply to equal the third term, the third number, but add to equal the second number. So in this case, we're looking for 2 numbers that multiply to equal +9, but add to equal -6. In this case, those 2 numbers are -3, and -3. So -3 times -3 is +9, and -3 plus -3 is -6. So we are going to use -3 in order to factor that perfect square trinomial. And that will look like this. We are taking our parentheses and we are getting rid of the squared on the inside to show that x minus 3 times x minus 3, so 2 of those, will equal x squared minus 6x plus 9. So now we have x minus 3 quantity squared, and we're just going to add on what we had on the outside before. We're almost done. Now we just need to perform the operations on the right side of your factor. So on the right side we have -9 plus 10, so -9 plus 10 is +1, and we are all done completing the square. Now you try. Pause the video and complete this example on your own. Then play the video and check your work. Here is the worked out solution for number 2. So notice that for this perfect square trinomial right here, we had to think to ourselves, what two numbers multiply to +36 but add to equal +12? That would be +6 and +6, so we have x plus 6 quantity squared to account for those two positive 6's. Next, we're going to take a function in general form and complete the square to put it into vertex form so we are able to graph it. So the first thing I'm going to do is make sure that my equation equals y or 0, which it does, and the second is to make sure that my a value is 1, which it is. So I'm going to start by sliding my c term over. So I have y is equal to x squared minus 8x plus square minus square plus 9. In order to figure out what goes in those squares, I need to do b divided by 2 quantity squared. So b divided by 2 is -4. When I square -4, I have +16. So +16 gets plugged into the squares. Next, I'm going to group off my first 3 terms to form a perfect square trinomial. In this perfect square trinomial, I'm looking for what two numbers multiply to equal +16 but add to equal -8. Those two numbers are -4 and -4. So this perfect square trinomial factors to x minus 4 squared because I used the factor x minus 4 twice. Now we add on the numbers to the right. And finally, we perform the operations to the right. X minus 4 quantity squared minus 7. So now that I have my function in vertex form, I can identify my vertex. My vertex will be the opposite of the x value in the middle. So my x coordinate of my vertex will be a +4. And my y coordinate of the vertex is the same as the outside, so -7. I'm going to graph the vertex. Now for the remaining points on the graph, I'm going to use 1a, 3a, 5a. My a value is 1, so I have 1 times 1, which is equal to 1, 3 times 1, which is equal to 3, and 5 times 1, which is equal to 5. I've now created my slope over 1. So from my original point, I will go up 1 to the right 1 and to the left 1. From those new points, I'll go up 3 to the right 1 and left 1. And finally, up 5 to the right 1 and left 1. Connect those points to make your quadratic equation, or parabola, actually. And now, finally, I need to identify some of my main characteristics of this parabola in the table at the right. First thing I will fill in is the vertex, because the vertex tells us a lot of information about the other characteristics in the table. So 4, -7 is my vertex, which helps me identify the axis of symmetry. The axis of symmetry is the line that goes through the x coordinate of the vertex, so this will be x is equal to 4. Then I can identify that my graph has a minimum at the y value, which is -7. This y value also tells me where my graph will start with the range, from -7 to positive infinity. In the last two parts, my graph is opening up because my a value is positive, so my domain will be from -infinity to positive infinity. Last example. Pause this video and try this on your own, just like we did in the last problem. Then unpause the video and check your work. And there you have it. Please email me if you have any questions.